In section 2.2, we're going to be looking at the square root of a function. Today we're going to examine how the square root operation affects the graph of the function. You can determine how two functions y equals f of x and y equals square root of x are related by comparing how the values of y are calculated. So for the equation y equals 2x plus 1, okay, if we were going to graph that equation, okay, so the graph y equals 2x plus 1. So when x is 0, y is 1, and the slope of 2, my graph is going to look something like this. So there's going to be the graph of y equals 2x plus 1. Now we want to graph the square root of 2x plus 1. And to do that, we'll do that one in red. There's a couple of key things you want to keep in mind. Okay. Number one, we can only square root where values of the original graph are positive. So the lowest value I can go down to is the x-intercept. I also want to identify where the y value equals 1, because between 0 and 1, like we talked about last section, the square root of a value is greater than the actual value. And then after 1, this is where y is 4, so it's going to have a value of 2. This is where it's 9, so it's going to have a value of 3. So when I draw the sketch, try to exaggerate and have the root function above the function between 0 and 1 in the y direction, and then draw in the rest of the graph. So there would be your root function, the square root of 2x plus 1. So notice, wherever the original function is 0 or greater, that's the only place I can have a square root of that function graphed. All right, so now I'd like you to pause the video and try this one. You're given the graph 3x plus 1, and they want you to graph the square root of 3x plus 1. Okay, hopefully you've had a chance to try this one. So 3x plus 6, if I was to graph that, okay, let's graph that. So 3x plus 6, my slope is 3. So there's going to be the graph of y equals 3x plus 6. Okay, so there's y equals 3x plus 6. So now we want to graph the square root of this function. So again, wherever we have an x-intercept, that's where my root function is going to start. Y equals 1 on the blue graph is about right there. And then 4, the square root of 4 is 2. The square root of 9 is 3. So again, when you sketch this, it's going to look something like that. And again, if you zoom in, the graph of the function of the root is slightly bigger than the graph of the function between y equals 0 and y equals 1. So there would be the graph of your root function. The domain and range of each function, well, the domain for the blue function and the range for the blue function is x is an element of the reals and y is an element of the reals, the range. For the red graph, the domain is x is greater than or equal to -2, and the range is y is greater than or equal to 0. Invariant points are going to be where y is equal to 1, okay? And that would be the point, well, you'd have two of them. You'd have this point right here at 0 and -2, and this point right there. Okay, so the invariant points one of the points is -2 and 0. And the other one is where 3x plus 1 is equal, sorry, 3x plus 6 is equal to 1. And then if you solve for x, So x is going to be negative 5 over 3. So the other invariant point is going to be negative 5 over 3 and 1. All right. We kind of summarized this when we talked about sketching square root functions. So let's take a look at this guy right here. So if we wanted to graph the square root of 2 minus 5x squared, well, the first thing I would do is graph the function 2 minus 0.5x squared, okay? And if we were to graph this, okay, let's just make this bigger. So we're going to start with the square root of 2 minus 0.5x squared, okay? So if at negative 2, I'm going to have a value of 0 for my quadratic, and positive 2, I'm going to have a value of 0. When x is 0, y is going to be 2. So my graph of my function is going to look something like this. So there's the graph of y equals 2 minus 0.5x squared, okay? Now, to graph the square root of this, okay, all we have to do, again, my square root can only be 0 or above. I have two places where the y value is 1. So those are going to be invariant points right there and right there. And then I just take the square root of 4 as root 2. It's going to be somewhere down there. And then when you graph this, again, between 0 and 1 in the y direction, the red graph is above the black graph. And that's what the graph of your root function. So the red graph would be the square root of 2 minus 0.5x squared. Again, the domain for the red graph is going from negative 2 to positive 2, and the range is going from 0 all the way up to positive root 2. All right, let's try another one. So identify and compare the domain and ranges of the functions y equals x squared minus 1 and the square root of x squared minus 1. I guess in the original graph here, we didn't really compare the domain, but the domain here was x is an element of the reals, and the range was y was less than or equal to 2. Okay, so first of all, let's graph y equals x squared minus 1. And the graph y equals x squared minus 1 is a parabola that's going up, and it's been dropped, shifted 1 unit down. So I'm going to have 1 and 1, and I have the point 0 there. And my parabola is going to look something like this. So there's my equation, y equals x squared minus 1. Now to do the square root, again, those 2 points are going to be on my root function. If I examine where the original function has a y value of 1, it's right there. And therefore, my graph now is going to peel out in that direction and out in this direction. And there would be the graph of y equals the square root of x squared minus 1. And again, the domain for the original graph is all the reals. And the range is y is greater than or equal to negative 1. The domain for the root function is x greater than or equal to 1, union with x less than or equal to negative 1. And the range is y is greater than or equal to 0. All right, let's try one more. This time we have y equals x squared plus 4 and the square root of y equals x squared plus 4. Well, y equals x squared plus 4 is a parabola shifted 4 units up. So it's going to look like something like this. So there's y equals x squared plus 4. Domain, x is all the reals. The range, y is greater than or equal to 4. Okay? For my red graph, because this graph is positive all the time, my root function will exist every place. So the square root of 4 is 2. And all of the y values, if I square root them, are going to be smaller. So it's going to look something like this. So my domain is also all the reals. The range is y is greater than or equal to 2. So basically, to get the red graph, I take all these y coordinates, square root them, and plot them at the same x coordinate as it was on the black graph. All right, a couple of examples. So they want you to sketch the root of each of these functions. So again, I encourage you to pause the video and try these two first, okay? So again, for the first one, we want to look at the 0, which is right here. The y, where y is 1 is right here. Y is 4 there, so in the root function, it's going to be there. And the graph is going to look something like that. For my parabola, again, there's my x-intercepts. There's where y is 1. Y is equal to 4 approximately there, so the square root of that is going to be 2. So again, my graph is going to go out like that and out like that. I guess I should really exaggerate between 0 and 1. This should really be above. There we go. And that's going to be that graph there. Okay? All right, this is another linear one. We've seen this many times. Again, there's my x-intercept. There's where y is 1 at 4, 2. And my graph is going to look like that. All right, so now we want to find the domain and range of each of the following algebraically. So now we have to think of our transformations. Okay, again, remember, we have root x. Its basic graph looks like this, okay? So now let's take these transformations bit by bit. And first of all, a being -3. So we know that a is -3, b is 2, h is 4, and k is 1. So basically, -3 is going to flip my graph and stretch it horizontally, or vertically, sorry, down. So it's going to end up being, whoopsie, it's going to be a graph coming down this way. And then 2 is going to make a stretch horizontally by a factor of 1/2. That's not going to affect the range in the domain. So I'm looking to basically figure out where does this point here end up, and which way is the graph traveling? So first of all, multiplying by -3 is going to flip the graph this way. X minus 4 will shift it 4 units to the right, and k being +1 will move it up 1. So my final graph is going to look like this. This value is 4, this is 1. So my domain is going to be x greater than or equal to 4, and my range y is less than or equal to 1. Okay, for B, or for the second one, again, first thing we need to do is factor a -3 out. So this is going to become x minus 6. So in this particular case, I have b is -2, h is 6, and k is -2. So again, our base function, root x, goes like this. Now our transformed -3 is going to flip it, and it's going to go this way across the y-axis because b is negative. B being 3 is only going to stretch it by a factor of 1/3. Again, that doesn't affect the range of the domain. X minus 6 will move it 6 units to the right. And k being -2 will be down here. So my graph is going to end up being something like that. So my domain is going to be x is less than or equal to 6. And my range is y is greater than or equal to -2. Okay, so there's some key ideas that summarize section 2.2. And there's your assignment. So give those some practice, see how you do. And if you have any questions, you can ask me in class.